Today we are looking at section 7.2. It is a little on the longer side, so let's make sure we're quiet, ready to listen, and keeping up with the notes quickly, okay? So, our first vocabulary word for today is similar polygons. It's two polygons whose corresponding angles are congruent and whose corresponding side lengths are proportional. So, I am going to label these with the congruent angles, okay? So the corresponding angles are congruent. So angle A is congruent to angle E. Angle B, congruent to angle F. Angle C is congruent to angle G. And angle D is congruent to angle H. So basically similar polygons, they're the same shape, but not necessarily the same size. And when you're shrinking it or making it bigger, the angles actually don't change, the side lengths change. Okay? But all the side lengths are proportional, meaning their ratios are equal. So if I write a ratio for the side lengths, like AB over EF, see how those are corresponding? This ratio will be equal to the ratio of two other sides that are in the same positions. And so on, around the figure. So CD over GH will be equal to HE over, DA over HE. So see how, if I call this the bigger one, it looks a little bigger, right? Yes. So if I write a ratio of side lengths, bigger over smaller, it's equal to bigger over smaller. I almost flip-flopped them here. I lost my head for a second. But if you start here, you have to go to this one. This one over this one. This one over this one. This one over this one. Okay? Yes. All the side lengths are proportional. Yes, meaning the two that line up, the two that are corresponding, if you write them as a ratio, it will equal the ratio of two other corresponding sides. Oh, wow. As long as you're writing it in the same way. Like yesterday we kept doing like miles over gallons or, shots per second or whatever. Same thing here. This one over this one. Questions? That was a lot. I'll give you a second to catch up if you need to. So this example says, list all pairs of congruent angles. That's what we want to do for part A. For part B, we're going to write the ratios of the corresponding sides. For part C, we're going to check that the ratios are equal. And this tells you, very similar to those congruent statements we did last chapter, which parts are corresponding. The only difference is they're not all congruent. They're similar. So instead of putting the equal sign with like a squiggle on top for congruent, it's just the squiggle part. No equal sign. Okay? So part A, we want to list the congruent angles. Anyone know a pair that's congruent? P and S. So angle P is congruent to angle S. What else? RT. Angle R is congruent to angle T. And angle Q is congruent to angle U. Now, I want to write the ratio of the corresponding sides. So they give us the side lengths, so I'm going to use those. Okay? What's going on?
We put it on that A, B, and C.
I put them like this.
Oh, you just do it underneath. That's fine. Okay. So I am going to write the ratio for the side length. So in the previous one, we just put like PR over ST. Well, we have lengths now, so let's use those. Okay? So what's my first ratio? 10 over? Okay. And that should equal... Let's go around the figure. 20 over 16, which should also equal 15 over 12. Good. Now, to check that, I'm just going to reduce all of them. So what does this reduce to? 5/4. What does this reduce to? 10/8. And then?
Wait, can't you reduce that to like 5/4? Yeah.
5/4. 5/4. So are they all equal?
Yes.
Yes, very good. Questions? Same idea on number 2. I want to first list all the congruent angles. So, So angle J is congruent to angle N. And if you're not sure where to start on the figure, look up here. Okay? Angle K is congruent to angle P. Angle L is congruent to angle Q. Angle M is congruent to angle R. Very good. Questions?
No, ma'am.
All right, now I'm going to write a ratio of the side lengths. And I'm going to go in this same order. So JK and P is where I'm going to start. JK is how long?
3.
And NP? 2. Good. All right, next I'll do KL and PQ. So KL is 3. PQ is 2. LM is 6. So LM should go with QR. 4. All right, and then the last side.
KL.
So 4.2 and 2.8. Okay. Now, let's reduce all of these and see if they really are equal. 3 over 2 is 3 over 2. 3 over 2 again. 3 over 2 again. What is 6 over 4 reduced to? 3 over 2. Now, this one, I would actually get rid of the decimals first. So I would multiply them both by 10. So 42 over 28. 14 goes into both of those. How many times does 14 go into 42? 3. How many times does it go into 28? 2. It's pretty easy when you see what it's supposed to be, right? So that's how you reduce with decimals. Just get rid of the decimals first and then reduce. And you get rid of the decimals by multiplying top and the bottom by a factor of 10. Next vocabulary word is scale factor. It's the ratio of the lengths of 2 corresponding sides. So basically what we did between part B and part C, where we reduced all the side lengths, all the ratios of the side lengths, that's actually the scale factor. So if you understood the last example, you'll be great at this. So the ratio of the lengths of 2 of the corresponding sides. So for example, if this was like 3 and this was 2, the scale factor would be 3 over 2. The tricky thing with scale factor is it tells you which way to do it. So it'll say like the scale factor of A, B, C, D, 2, E, F, G, H, and that would be 3 over 2. It might say, though, the scale factor of E, F, G, H, 2, A, B, C, D, and you'd have to use one of these lengths first, then this one, okay? And we always reduce with scale factor. Any questions? So, I'm going to look, before I start writing any proportions, at this last part. Find the scale factor of figure B to figure A. So that means that this guy is going to need to go on the top of my final answer. So when I'm deciding if they're proportional or if they're similar, I'm going to put that one on top. I'm going to just kind of cut right to the chase, okay? So, which side from figure A goes with the 12?
HG. HJ.
This 12.
9.
GH.
Yes, which is 9. So I'm going to put 12 over 9 first. All right, now I'm just going to go around the figure. And again, I'm putting B on top because my final answer, the scale factor, is going to have B on top because it says figure B to figure A. Okay? All right, so which one goes with the 16?
12.
The 12.
20.
And which one goes with the 20? 15. Double check all of the top numbers are from figure B. All of the bottom numbers are from figure A. Now, in order to be proportional, or in order to be similar, these need to be proportional, which just means they have to be equal. So I am going to now reduce them all. 12 over 9 reduces to what?
3 over 3. I mean 4 over 3.
4 over 3. 16 over 12 reduces to what?
4 over 3.
4 over 3. 20 over 15 reduces to what?
4 over 3.
4 over 3. Good. So, are these all equal?
Yeah.
Yes. If all the ratios are equal, that means they're proportional, which means the figures are similar. So determine whether the polygons are similar. I'm going to put a yes. Yes, they are similar. I need to write a similarity statement. Okay? So triangle what?
GHJ.
GHJ is similar, so squiggle.
MKL.
Triangle MKL. Just like last chapter, order matters. See how G and M are congruent? Hold on. See how G and M are congruent? They go in the front. See how H and K are congruent? They go in the middle. J and L, they go in the end. Now, could you have written triangle MKL is similar to triangle GHJ? Yes. You don't have to, though. It's kind of like an equation where you could put like 3 equals x or x equals 3. For the similarity statement, it doesn't matter which one you put in the front. For the scale factor, it does. So what is my scale factor? The scale factor is the reduced ratio of the sides. They all reduce to what? 4 over 3. So there are 3 answers here. Yes, our similarity statement, and the scale factor, which is 4 over 3. So again, my final answer, this guy needs to be on top because I'm asked to find the scale factor of B to A. So where do you guys want to start?
PQ.
Okay, what's the length of PQ? Okay, now does that Should that be on the top or the bottom?
Top.
Bottom.
Bottom.
Does anyone have a justification for their answer?
B goes
That's
to
what you
A.
told us that we were gonna do.
Yeah, we need to start with the numbers from figure B, because when I write my scale factor, we want the scale factor of B to A. So B needs to be on top. So 10 over 12 equals what? 6 over 9. Now, if these reduce to the same numbers, then these rectangles are similar. All right, what's 5 over 12 reduced to? Or sorry, I kind of said it. What is 10 over 12 reduced to?
5 over 6.
5 over 6. What is 6 over 9 reduced to?
3 over 3. 2 over 3.
2 over 3. So are these proportional? No. So are the figures similar? No. If they're not similar, you cannot continue with the problem. You can't write a similarity statement if they're not similar. You can't find a scale factor if you're not looking at two similar objects. So once you recognize that it's a no, you're actually done. All right, for number 5. Now they're giving us the similarity statement. So triangle RST is similar to triangle GHJ. We are supposed to find X. Now, we are going to write a proportion. So I always start with 2 sides that I know. Sometimes you know all the sides but one. Sometimes you only have 1 pair of sides you know and then one that you're looking for. So just start with one you know. I know 10 and 15 can be written as a ratio, right? So that's where I'm going to start. 10 over 15. 10 was from this guy, the smaller one. So when I write my next ratio, I need to make sure that I'm starting with the smaller one. That's the X. X goes with which number? 9. Now, if you want to keep going and say also equals 8 over 12, you can. You don't need to, though. This is enough information to find the X. All right? How do I solve something like this? I cross multiply. So 90 equals 15X. All right, what does X equal? 6. Very good. So it's a lot like what we did Monday. You just have to write the proportion first using the skills we talked about today. Questions? All right, here's the next one. Now, in this one, we have a little bit of less information. Like I said, we can only really write 2 ratios, but 2 is all you need. Does someone want to attempt to set it up for me?
Yes.
4 over 6.
Does it matter? For the first one, it doesn't matter. But if you start with the 6 and then go to the 4, you better be starting with the X and then going to the 8. Okay?
Yeah.
Yes, sir.
Do you understand why?
Yes.
Yes.
Don't mix it up. Oh, yeah.
Could I just find like the ratio?
Hold on 1 second. All right. I disagree with what we have on the board.
Wow. It was my way. But
48.
We ignored something very important.
all the thing.
Yeah. I don't think that the 6 and the 4 actually go together.
And then what? It's the opposite side.
Because if I look up here, CD goes with which side?
L-M-N.
K-L. No, M-N.
Okay. And X is BC. Those are the middle two. LM. So this diagram is misleading on purpose. Okay? This is one of those tricks to make sure that you're actually looking at this statement right here. So you can never in geometry go like, well, it looks like it. Okay, you need evidence. And this is the evidence we have. Now we can cross multiply.
8x equals 24.
So 8x equals 24. So x equals 3. Very good. Next, we're going to look at the perimeters of similar polygons. So if two polygons are similar, then the ratio of their perimeters is equal to the ratio of the corresponding side lengths. So basically, that scale factor holds true if you're talking about one side from each, or if you're talking about the sum of all the sides from each, okay? So here is our next set of examples.
Yes.
All right, first we want to find the x. Anyone want to help me out with this? Yes. Tell me how. Right of proportion. Somebody help me out here with a proportion. What is it? 14 over 7 equals x over 9. Cross multiply. So 7x equals
126.
Thank you. And then divide 126 by 7. So x equals 18. That's my first answer. Questions on that one? Next, I want to find the scale factor of triangle PQR to triangle STU. All right, so scale factor is just the reduced ratio of the side lengths. Doesn't even matter which sides you pick. Pick one from one from the other. Make sure they're corresponding. So, which triangle needs to go first? PQR. Give me a side length from PQR. 14. Now give me the matching side from the other one. 7. That reduces to what? 2 over 1. Keep the 1 on the bottom, okay? Remember, ratio is a comparison of two numbers. Scale factor is the same thing. 2 to 1 is the scale factor. So, what part is confusing? Okay, so scale factor just says if you set up a ratio of one to the other and reduce it, what would you get? So see how each one of these would reduce to 2 over 1? All right. Now, the next one says find the perimeter of PQR and the perimeter of STU. So what is 14 plus 16 plus 18? What is it? Okay, so I'm just going to draw a little arrow. This one's 48. This one is what?
Why number 7? Why is 20? That's 24.
50, yeah, this would be 24. Now it's saying what's the scale factor of their perimeters. You just wrote down that the scale factor of the perimeters is the same as the scale factor of the sides. But we can double check. So the perimeter of the first one was 48. The second one was 24. What does that reduce to? 2 over, it better reduce to the same thing or we've made a mistake somewhere in here. Questions? Okay, same idea here. We have 2 figures. We are given that they are similar. I'm going to label the angles because they look like they might be kind of hard to distinguish. So P and S are already labeled, right? Q goes with T. So this one and this one. And then angle R goes with angle U. So you kind of have to spin it, right? Okay, so I want to find X. So pick a pair that you know. Now, 36 and 10 are not corresponding, so don't pick those. 36 goes with 24. Okay, and if you're unsure, go back to your P, Q, S, T. P, Q, S, T. So I can do 36 over 24 equals, the X goes with which one? So X over 26. All right. Let's cross multiply. 24x equals, someone's going to have to help me out with this one. What is it? All right. And don't clear it. Just divide it by 24. All right. So there's my x. Next, I want to find the scale factor. Pay attention to the order. Triangle PQR. So this one on the right, PQR first, to STU. All right, so give me a side length from PQR. PQR. Okay, and 15 corresponds with which one? 10. All right, reduce that. That'll be your scale factor. 3 over 2. Now, check it out. This one is also 3 over 2. Once we found this guy, if you plug it back in, this one also reduces to 3 over 2. That's not a coincidence. All the ratios should reduce to the scale factor. Okay? So I'm going to skip 13 for a second. What's the scale factor of the perimeters going to be? 3 over 2. It should be the same, but let's find the perimeters just to be safe. So PQR. So 15 plus 36 plus 39. Okay, what's the perimeter over here? All right. Well, it doesn't say to write them as a ratio, so I'm just going to write the 2 numbers. So 90 and 60 are our perimeters. And yes, if you set those up as a ratio, they will reduce to 3 over 2, the same as a scale factor. Again, not a coincidence. So there was a ton of information today. I highly recommend doing your homework tonight. We only have about 6 minutes. We will review all this stuff tomorrow, and you have a quiz on Friday.